Hi, in this video we will discuss the concept of sinking and floating. So what comes to your mind when you come across the word sinking and floating? This is basically the terms which is normally applied in our daily life. I will start by showing you the following examples. Here, this is the plastic material. You can see it. What happens when you immerse it in the beaker? This is the beaker, which is actually full of water. You can see there is water inside this beaker. So I will place this plastic material inside this water. What happens? That plastic material, you can see it floats. It is above the surface of the water. Let us see another case. What happens when we take now the piece of the stone? This is the piece of the stone. You can see it, and we immerse it in the beaker containing liquid. You can see the stone is actually sinking downward into the beaker. So that is sinking. But when you put this plastic material, you can see it floats. You can see the difference between the two. This is the flotation and this is sinking. So basically sinking, it is the tendency of an object to fall to the lower levels in the liquids. That is sinking. The tendency of an object to fall to the lower level in the fluid or in the liquids, that is sinking. And the floating, it is the tendency of an object to remain above the surface of the liquid. You can see it is above the surface of the liquid. That is flotation. All right? Okay. So now we will see what are the necessary conditions that makes an object to float. Conditions for the body to float and sink, or for flotation. What makes an object to float? Of course, there is different things that makes an object to float. The first thing is that the apparent weight of that body must be zero, because the weight in water must be zero, otherwise it will sink. So the apparent weight of that object when it is in water should be zero. Is zero. This is the first condition. It is weight, basically it is zero when it is above the water surface. There is no weight in water. That's why it is just above the water surface. All right? That is the first condition. The second condition for the body to float is that the object normally which is having very low density, they floats. If an object, its density is less than the density of water, then that object will actually floats. So its density should be less. Its density should be less than the density should be less than the density of water. Say it should be less than the density of water. This is the necessary also condition for the body to float. But also, the other condition that is very necessary for the body to float is that basically it is weight in air. It is real weight should balance with the upthrust. If these two terms they are balanced, then of course the body will float above the water surface. And this is because we understand that the upper thrust basically is obtained by taking, we take weight in air minus apparent weight. Remember, when the body is floating, the apparent weight is 0. This is 0. Because when it is above the water surface, there is no weight in water. It is 0. So you can now equate and say that the upper thrust must balance with the weight in air. So these are the 3 conditions that are the necessary for the body to float above the water surface. All right? Okay. So after now looking at the concept of sinking and floating, let us see now the principle of flotation, or the law of flotation. The law of flotation. Basically, the law of flotation, it states that the floating object, any object which is floating, it displaces its own mass or weight in which it floats. The floating objects displace its own mass or weight in which it floats. Alright? So you can write that the mass of object will be equal to the mass of water displaced, because any floating object it displaces its own mass or weight in which it displaces. That is the first thing to understand. The other thing is that the weight of the object is equal to the weight of displaced water. This is the displaced fluid or water. This is the principle of flotation. So basically, let us take the following scenario. For instance, this is the beaker. This is the beaker, which is full of water up to a certain level. This is some amount of water which is inside this beaker. Let us assume that we are having the ice. You know, the ice now is placed inside this water. What happened? This ice might float. So we understand that basically the upper thrust is equivalent to the weight of the fluid displaced according to Archimedes' principle. So we say the upper thrust is weight of fluid displaced. This is displaced. So this weight of the fluid displaced can also be obtained by taking the mass of the water displaced times the gravitational force. The mass of the water displaced times the gravitational force is the weight of the fluid displaced. So let us assume that, of course, this is the ice which is placed above the water surface, and let us say the total volume of this ice is V. This is the total volume of this ice. And when it is in water, it displaces a certain volume because it is submerged. You can see it has the volume when it is in water. Let's say this is volume of water, VW. So basically we can calculate the fraction or the amount which is below the water surface, and also we can calculate the fraction which is above the water surface. What can we do? Because this upper thrust will be equal to the force of this object, because upper thrust is the force. So this can be obtained by taking this is the force, it is the mass, let's say, of ice, this is ice, times the gravitational force. This is upper thrust, which is the force. Remember, force is mass times gravitational force. So we can take the mass of ice times the gravitational force. This will be equal to the mass of the water displaced. You can see there is the place whereby this ice has displaced some amount of water. So we take the mass of water times the gravitational force. Remember, the ice has the certain volume, as also it is density. So we said that the total volume of this ice is V. So we understand that mass is the density times the volume. So mass of ice, we can write it is the density of ice times it is the total volume, which is V, times the gravitational force. This will be equal to mass of water can be obtained by taking the density of water times the volume of water, which is VW, times the gravitational force. So this gravitational force and this gravitational force cancel it out. So density of ice times the volume of ice, this will be equal to density of water times the volume of water. So in order now to calculate the fraction submerged, you can calculate the fraction submerged, which is below the water surface. It can be calculated by taking, we can write V of water divided by V, which is the total volume. This will be equal to, we take the density of ice divided by the density of water. This will be the fraction of the amount of ice which will be below the water surface. All right? Okay. So for instance, the density of ice is 0.9 and the density of water is 1. So you can calculate the amount the fraction which is below the water surface as 0.9. So the fraction now which is which is below the water surface will be 0.9. Right? So in order now to calculate the amount which is above the water surface, what can you do? Of course, in order to calculate the amount which is above the fraction, you can say the fraction which is above water surface, fraction above water surface. Of course, you basically take 1, you minus the volume of the water divided to the total volume. You get the fraction now which is above the water surface. So this can be obtained by taking V minus V of water divided by the total volume. So this will be the amount which is actually above, the fraction which is above the water surface. All right? But also you can use the density. You can take the fraction which will be above the water surface. You can take 1 minus, it is density of ice divided by density of water. So you can obtain also the fraction which is above the water surface by using density of water minus density of ice divided by density of water. All right? Thank you for watching. Don't forget to subscribe. See you then in the next video.